In this last lesson for chapter 35, we're going to take a higher order equation and convert it to a system and then solve that using the Laplace transform method. Section 2, or lesson 2 in chapter 35 was on converting higher order equations into systems. Lesson 3 was on solving with the Laplace method. We're going to take this problem, which is an example in chapter 20 in your book, using what our textbook author called the method of guess. And we solved that, or your author solved that in the book. You can go take a look at examples 20.1, 20.2, and 20.3 in your textbook to see how that was done using the method of chapter 20. We're going to use the method of chapter 35, which is to change this into a system. Now, the first order of business is to change our variables. Now, the equation, as it was stated in chapter 20, was obviously y as a function of x. We are simply going to change that to t's. Now again, this was lesson 2 of chapter 35. We're going to use x equals y prime, which would make x prime equal to y double prime. Well, from our original equation, you can see if we move the 2y prime and the 3y to the other side, we would have y double prime equals 36 e to the 5t plus 2y prime plus 3y. And if we now replace the y prime with x, we will have this. So here is our system of equations. Now, to solve this system using the Laplace transform method, we need to do the Laplace transform of each equation. So for the first equation, we would have the Laplace transform of the left and the Laplace transform of the right. And we will split the one on the right up into its individual pieces. Then we will look all of these up in our table. Now, the Laplace transform of x prime, remember, is s times Laplace of x minus x of 0. And we already know from here what x of 0 is. And leaving the Laplace x and Laplace y alone, we can convert Laplace e to the 5t using our table. That's 1 over s minus 5. So there's a 36 over s minus 5. Now we want to collect all the Laplace x and Laplace y's on the left and everything else on the right. So moving those terms around, this is what we would have in standard form. Now the next one is a little easier to convert. We do the Laplace transform of y prime and the Laplace transform of x. On the left-hand side, again, we looked that up in the table. That's s Laplace y minus y of 0. Now y of 0, we're told, is a 9. So writing that in standard form, this is what we would have. So here's our system of linear equations. If we're going to use the Gauss-Jordan method for solving that, this would be our augmented matrix. And again, I would just type that into my TI-89, do the RREF, and store that as a new variable. In this case, you can see I'm using the variable n. Then I would simply take these two and convert them using the inverse Laplace transform. Of course, to find those in the table, we've got to expand using our TI-89 and then look this up in the table. Now, if you remember from back in the beginning, we don't really care what Laplace x is, so we're really just trying to find y, which there is our Laplace transform of y. We need to go look these up reverse in the table. The 2 over s plus 1 converts into e to the negative t. The 1 over s minus 3 converts into e to the 3t. And the 1 over s minus 5 converts into e to the 5t. And again, you can go look at chapter 20 in your textbook where they solved that using a different method and see that we came out with the same answer as the other method.